question will be on the
I
camera.
just hit the record button. Hello, Leah.
Don't you like split it in half, two things?
You can, but you don't have to. So this is a compound inequality. It has two, it's saying two different things. It's saying that 4 is smaller than 3x minus 2, but it's also saying that in turn, 3x minus 2 is smaller than 13. This is called a sandwich. It is very important that you recognize that this only works if the transitive property applies. In other words, if I were to say I am older than Justin and then Justin is older than, I don't know, kindergartner, then obviously I would be older than the kindergartner. That's transitive property, okay? So if 4 is smaller than this and this is smaller than 13, then 4 should be smaller than 13. Like it's all true.
Indeed, amongst
Therefore,
large
this is a
summation.
perfectly great example of a sandwich, of an inequality that works with transitive property. So, I would not suggest that you make it into 2 parts because I think that you're old enough and mature enough to handle it. But technically, yes, you are saying 4 is less than or equal to 3x minus 2, and 3x minus 2 is less than 13. And so if you chose to, you could actually solve 2 separate equations and get 2 separate answers. But an and implies that your solutions are going to be numbers that make both equations true at the same time. It's an intersection, right? The symbol for and is this, by the way.
That doesn't sound very tasty.
But this guy, Josephus, she's going to hear everything you're saying. Okay, so knock it off. All right, so we're going to go plus 2, plus 2, plus 2. So see, Ethan, you don't actually have to do 2 separate cases. You can just do it all at the same time. And you're not even writing this down. So you kind of work from the inside out. So it's kind of like having 3 sides instead of just 2 sides of an equation. You have like 3 sides. But anyway, because if you think about it, over here, Ethan, to solve for this, I'm going to have to add 2. But I'm still going to have to add 2 here. So why add 2 twice when I can just do it once? This is just shorter. But then x is less than 5, less than or equal to 2. So you'll notice that when you have your number line, and I'm not convinced, I don't know, I'm not exactly sure that they're actually asking you to graph it on the number line, but if I were to graph it on the number line, there would be a 0, there would be a 2, there would be a 5. And then if x's are less than 5, that would be open, and you'd be going this direction, right?
Mm-hmm.
But if x's are also bigger than 2,
Close.
and you're going this direction, so you see you end up with this, like, all these numbers in between satisfy both conditions at the same time. Does that make sense? The number 0 will satisfy the fact that it's less than 5, but it's not bigger than 2, and it has to satisfy both at the same time. So that's why the only answers are what's in between here. So some people like to do shading, some people like to do the arrows. I will tell you that now that we've graduated to pre-cal, you should not be doing either. Your graphs should look like this. And I am going to hopefully transition you to that. I know it's not going to be the easiest transition ever, but you should have, for an open circle, you should have a parenthesis that is facing the direction that the shading would be. So I'm not going to make it this direction. The parenthesis is facing that way. And then because this is a closed one, we have a bracket for that. And that would be like this. And everything in between.
So it's just like when you're writing numbers, except
there's no elementary arrows in pre-cal. You will never see any graphs in your pre-cal book that have these arrows going like this. That's just, not to be mean, but it's like a very elementary, childish way of drawing the graph. And so apparently, you're a pre-cal now, it's not to be considered a childish thing.
Are you recording?
I am recording, but it's just for Leah's.
This
Hi,
is
Leah.
Leah.
Hi, Leah.
Anyway,
What
she's
I
not
want
here
to
today,
be,
so we wanted to
nope.
help her
See
out.
ya.
Why do you have presents? Are those for me?
Ha.
I guess not. Okay.
No, it's for Desi.
Jesse.
Tessa.
Oh, how sweet. Okay, so any questions about how to solve a compound inequality? Ethan, I'm so sorry that you're so bored right now.
No.
There's also a general
Okay.
question, I think, maybe probably.
All right. I'm going to now give you one of your worst nightmares. Leah, pay attention,
Oh my,
okay?
that's really hard.
Is this?
I thought you were referring to
word
my whole
problem.
nightmare thing, but apparently you have your own nightmare going on over there. Okay. So, we're going to talk about non-linear inequalities. Okay, non-linear. So, what you just saw, the previous example was totally linear. Okay, x to the 1 power. Anytime you have an equation that is not linear, unfortunately, you will have to use this little thing called test intervals. Everyone will hate it. No one will like it. It is required. If you don't do it, you don't get credit for the problem. Okay? Just being clear with you, okay? So for example, we're going to do one right here. It is x squared less than or equal to 5x minus 6. And by the way, I didn't say it earlier, and it didn't come up earlier, but I hope that you all still remember that whenever you divide by a negative, the inequality symbol does switch, right? It flips around, okay? A greater than becomes a less than becomes a greater than whenever you divide by a negative. Okay, but we didn't do that in the last problem, so it wasn't a big issue. This is a quadratic. It is not linear. And before we even get started, we're talking about, first of all, we would make it into like something that you're more used to. See, the problem with inequalities is that the way that we solve them is the exact same way that we solve equations. True or false? I'm going to solve this the exact same way that I would solve if it had equal to.
True.
The previous question that I just solved, I'm going to solve it the exact same way, only it has an inequality symbol. So the only difference is that in this case, I get, like if this was an equal sign, like if, then I would have just got x equals 2 and 5. And when I graphed that, it would have just been one dot. 2 and 5. That's it.
Well, 2 dots.
Right?
Yeah.
We call that finite solutions. I can count how many solutions there are. Finite. You know what the opposite of finite is? Infinite. Infinite. Okay? How many numbers are actually less than 5?
1,000.
Infinite amount of numbers. How many numbers actually equal 5?
1.
So you can count the number of solutions that you have with these kind of problems. Once you have an inequality, it becomes infinite. So the solutions are the problem. So when we look at this guy, there's no doubt in my mind that we can factor this. Let's see, 2 times 3, right? Will give us a 6. If they're both negative, they will add to negative 5, correct? So, but that's no different than if it was an equal to, right? We would still factor it. So I'm still factoring, nothing new under the sun. And really, all I can really say is that when x equals 2 and 3, that this function is equal to 0. Right? That's all I really know right now. I know that when x is 2 and when x is 3, this equation is equal to 0. But is that what they're asking me?
No.
Are they saying that x or that the 2 and 3 are when it's equal to 0? Is that what they want me to know? What do they want to know? What do they want me to know? They want me to know when it's less than 0.
Less than.
Not equal to 0. Less than 0. When is it less than 0? So here's the, problem number 1. Most students, when they first see this, they go, oh, well, just, put the symbol in there. Okay, so according to you, x is less than 2 and less than 3. Okay, so here's 2, here's 3, you're less than 2, you're less than 3, so you're less than 3? Is that, so, do you see what I'm saying? Problem. What does a parabola look like?
It looks like a U or an upside down U or a sideways
Well,
U.
this is a positive parabola, so it's not going to be upside down.
Just a normal U.
If it was negative, then yeah, it would be like this, right? Negative x squared. Positive x squared is like this.
Whoosh. Oh, and so the intersection points are 2 and 3.
And this is 2, and let's pretend this is 3. Let's pretend. Obviously, I didn't graph it totally right, okay? But
Not
just
to
gives you an idea of what's happening here. We know the parabola is positive, so we know it's going to look something like this. We know that when x is 2 and 3, it's going to equal 0. So this is 2, and this is 3. But I want to know when the graph is less than 0. Where's the portion of the graph that's below 0? Between 2 and 3. Not all the way less than 3. values between 2 and 3 are less than 0. When is it greater than 0? Because I could easily change that around to a greater than symbol. If this was a greater than symbol, all of this would still be the same.
When it's greater than
But the
2.
solution would be different, right? The greater than would be this piece and this piece. This is what we call an OR. It would be from negative infinity to 2, right? Or from 2 to positive infinity. It'd have to have a little union. Negative infinity to 2, right? And from 3. Does that make sense? Do you understand what's happening there?
Yep.
Yes.
Now, without actually graphing the parabola, because at no point in time did they actually ask us to graph this. So without actually graphing it first, how can we know what to do if we're not graphing it? I mean, you can see this because I graphed it for you, but what if you're not graphing it? That's why we need
Looking
test
between
intervals.
numbers, maybe.
Okay,
Yeah.
so I'm just warning you right now that you're not going to have to keep graphing it. That's not the point. But I wanted you to see kind of what's happening, okay? So then what do? How do we approach these nonlinear inequalities? Well, instead of thinking of these as solutions, we think of them as what we call critical numbers. Kind of like when you're in the hospital and you're in critical condition in ICU. What does that mean? That you probably need extra
But you
care,
haven't seen.
extra evaluation. You're not going to put you in the regular ward where no one's going to come see you for like 10 years.
Die.
Well, yeah, you might die, but we're not going to die here. What I'm saying is that it means that it's a critical value. It matters to us. And so we have to go in and investigate around those numbers, okay? So what these critical numbers are used for is you are now going to separate the entire number line into sections based on these numbers, okay? So since my numbers are 2 and 3, I have 3 intervals. Negative infinity to 2, from 2 to 3, and from 3 to infinity. Does that make sense?
Yes, that makes a lot of
You
sense.
have to take your entire number line, and where you have, if you have 3 critical numbers, it means you're going to have 4 intervals. Because every time you have a critical number, you have to like split the number line into different sections. Does that make sense?
Yeah.
Yes, Josie?
So for each interval, you pick a value within
Yes,
that
and you
interval, and
test
then you
it.
test it.
And you test it.
Or well,
okay?
really, in this case, you'd only do it with 2, right? Because because parabolas are symmetrical.
No, I'm
You
still
could just
going
do
to
it with
test
the
it
middle
all.
line.
We're not going to
There's
base it
no-
on that. No
But-
cheating.
But
But nothing. Okay?
but
So,
Huh.
do you understand the portion about the intervals?
yeah.
You have to make those intervals, okay? So then, over here, you're going to make like a little chart.
Indeed, I'm
Over here, you're going to have your factors, x minus 2, x minus 3, and then both. I'm too lazy to write them both, but this is like this factor by itself, this factor by itself, and this is the product of the 2 factors, which is exactly what we have here. Right? So it's very simple to do this, okay? Other than the fact that people don't want to do it, but now you have to pick a representative. You know what that means? Like if I said we need 1 person from each class, it would not count to have 3 freshmen and 1 senior. That would not be representative, okay? So you need somebody from each interval, okay? So I will tell you that anytime you go from a negative to a positive, the best number to pick is 0. Because it's so easy to plug in 0, okay? Sometimes you can't do that because one of the critical numbers is 0. But in this case, between positive and negative, there has to be 0, right? Over here, we don't really have a choice. The only thing we can really pick is like 2.5. I mean, technically you could pick 2.1, but 2.5 is between 2 and 3. And then you want to pick like 4. Obviously, you could pick 100, but why would you want to pick a number that's so big? So just try to keep it small,
It's a nice number.
okay? And try to keep it integers if you can. In this case, we couldn't keep it an integer, but if you can, try. And then you just make a little table. You say, when I plug in 0, what's 0 minus 2? Is it positive or negative? I don't care what the value is. Is it positive or negative? What's 2.5 minus 2? Positive or negative? Positive. What's 4 minus 2? Positive. Okay? What's 0 minus 3? Negative. What's 2.5 minus 3? Negative. What's 4 minus 3? Positive. And then when you have a product, a negative times a negative is a positive. A positive and a negative is a negative. A positive and a positive is a positive. So they want the negative. They want the product to be negative, less than 0. Right? That's what they want, less than 0. So which of these is less than 0? All you're looking at now is the bottom row. Both together. Which one of those intervals is the one that you want?
Clearly the middle one because
Middle
it's
one,
less
it's
than
negative.
0.
Negative, less than 0. Right? So my solution will be 2 and 3. And because this has an equal to on it, it means that I can put brackets. Does that make sense? So if I had made this a greater than, then the answers would have been these two intervals. Does that make sense? This is the first time we've done it. We're going to do it again, so don't get all crazy with me if you haven't fully understood it yet. We'll try another one right now.
But strictly speaking, you'll really only have to do one of the two outermost ones if you're working with a parabola, right?
No.
Oh, right, because then you don't have the
Strictly
other.
speaking, could you figure that out? Yeah. Strictly speaking, I could just look at it myself because I'm so ingenious here. I could just tell you right now what the answer was going to be. But strictly speaking, you're a student, and you will do as I say if you want full credit, and you will not be using that shortcut.
Understood, master of
Understood.
the universe.
Awesome. Okay. So are we okay with this?
Yes.
All right. So now let's try another one, because it's probably all we're going to have
Is that how
time
it's
for.
pronounced, Katie?
Okay. I have no idea.
Caveat.
I'm just a poor boy
Caveat.
from a poor family. What is this? Example what?
4.
Okay. We don't have Leah here. She's always telling me which ones I need, and I don't know, Leah.
Wait, what was example 1?
See, I don't know.
It didn't exist, remember? She
We
went
just
straight to
started
2 because it
We
was.
started on 2. That's right. Okay.
Wait,
Well, someone said wait.
this is the calendar problem, like example 3.
This is another interval problem.
Okay.
It's not quadratic. So it's not like the previous example in that way. Because with the quadratic, you only get 2 solutions.
You're at about 17 minutes, just so you know.
I know.
So
I can go to 30, and I know that that's probably when the bell's going to ring. So,
we have time.
so what's your question? Did I answer your question? Yeah, okay. So, most common mistake, this is actually a 4th degree. I don't know if anyone's noticing that. This is actually four answers. It's a 4th degree. We've got x squared times x is x cubed times x again is x to the 4th. This is actually 4th degree. So this is, again, non-linear. It's not linear. Linear would be x to the 1 power, okay? So first mistake people make sometimes is they try to make things harder on themselves. This is already factored. There's no point for you to go in and try to multiply everything out. No one is asking you to go x times x, no. It's already factored. If you will remember from the previous example, the first thing we did was factor it. So if anything, in example 4, they've already done that for us. Does that make sense? So don't undo it. Go from there. If they've already factored it, then that means that you can find your critical numbers very easily. This guy gets missed a lot because he's all here by himself, but this is x equals 0. Okay, that's a critical number. Don't ignore him. X equals 0. If x is 0, this whole thing will be 0.
Right.
So x is definitely a critical number. So then here, this one is the same factor 2 times. Remember from before, multiplicity. It's the same factor 2 times. So we're going to get x equals 1. But we're going to get that same number twice. So we don't have to write it down twice. Just know that it's going to be a 0 twice. All right, and the last one's going to be what? X equals
3.
3. Okay, so now we have 3 values. So we're going to have to split our number line into 4 intervals. So it's not rocket science. Always start with negative infinity, because that's where the number line begins on the left, right? Negative infinity. And go all the way up to the smallest number that you have in your list. Usually that number is negative. In this case, it's not. What is the smallest number that we have?
0.
So that's my first interval. The next one goes from where the one before it ended to the next number, which is,
It's 1.
and then from 1 to 3, and then from 3 to the end, which is positive infinity, which is why you get 4 intervals. Okay, lucky us, yay. Then we're going to put all of our factors. We're going to put x minus 1 squared, and x minus 3. And then we're going to put all. Like, what is the combined result? who are our representatives? You can't pick 0. So over here we're going to pick -1. Here we're going to pick 0.5. Here we'll pick 2 and 4. Are there any questions about the numbers that you picked? The good news is that I always check all your work. Like I know it sucks for me, but I always check all your process, like for a quiz in the future. And sometimes what I've seen the most common thing happen is, I already mentioned one, people forgetting the 0. That's a common mistake. And secondly, because of the negative situation, sometimes the number that you pick is not actually in the interval. Like you think it is, but it's not, and so then you test it, and it gives you the wrong values, and you have the wrong intervals. Does that make sense? So just be very careful that you are actually picking numbers that are in the interval. So -1 would be negative. That's obviously positive, positive, positive for the x. The next one is kind of funny because it's squared. So when you square something, even if it's negative, what happens to it?
It becomes positive.
These are all positives. Because even if this number is negative, when you square it, it will become positive, right? And then here's the one with check. -1 minus 3 is definitely negative. 0.5 minus 3 is negative. 2 minus 3 is negative. 4 minus 3 is positive. And then we've got 2 negatives here, which are positive. And that positive, so positive. This dumb negative right here is going to throw everything off, making this negative. He's going to throw this off, making that negative, and that's positive. Okay, so we're only looking at the bottom row for our final answer. And we want to check over here that it says less than 0. So we don't want to include the endpoints, right? You don't want to, there's no brackets in this case. Last time we had an equal to, so you had a little bracket. Now there's no brackets. But they wanted negative, so they want these two. Okay, but here's the problem. You might be thinking to yourself, oh, just go from 0 to 3. You can't go from 0 to 3 because you can't include 1. Because 1 would equal 0. So unfortunately, we have to go 0, 1, and then union that 1, 3. If it had an equal to in there, then we could have gone from 0 to 3 because the 1 wouldn't have mattered.
So how do we graph this? It's
The
going to be
function?
positive over that side, and then
This is
negative.
a 4th degree, so I'm guessing it's going to look
So it's going to look like
something
a W,
this.
right?
It's going to look like that.
So it'll touch 0 at 1.
Yes, probably right here. Or something, yeah. But look at us, we don't have to graph it. So do you understand why we need intervals? It's not the same thing as an equal sign. They don't want to know when it's equal to 0. They want to know when it's less than or greater than or equal to 0. Alrighty? So that's that little guy. And then we have, let's see here. I'm going to try one more. I honestly don't know if we're going to make it because we only have like 10 minutes, but we might. Keep going, Leah. We got this. Okay. Example 5. Ejemplo 5. All right, here we go. 1 plus x over 1 minus x greater than or equal to 1.
Have a delightful picture of Bivens.
Okay. What are you doing?
I'm showing her this picture of Bivens. She had to see it.
She doesn't care, okay?
I'm sure you care, right, Leah? We can discuss this when you get back.
Okay, I really don't want to know all about that stuff. Just let it go. Okay, anyway. So, I'm going to call out my buddy my buddy Liza. This is Liza's little pet peeve. She does this all the time and it's so wrong. And she asks me every single time, why can't I do that? Okay, you can't do that, okay? You just can't. One of the things you're going to want to try to do right now is why can't I multiply both sides by 1 minus x? If anybody out there wants to do that right now, it's very bad, okay? You do not want to multiply by a variable because you're going to eliminate one of the solutions, okay? So you do not want to do that, okay? Cannot do that. What you do want to do is to force this guy to become one fraction and you want it to be equal to 0. So we're going to move the 1 to the other side. That's going to be 1 plus x over 1 minus x minus 1 greater than or equal to 0. You want to make it 0 over here. So whatever's on this side, kind of want to move to the other side. Okay, move to the other side. And then we want to combine those two into one fraction. So that would be for us to go 1 plus x over 1 minus x, and then this would be minus 1 minus x over 1 minus x. Because again, the same top and bottom is the same thing as a 1, right? Like 2 divided by 2 is 1, 5 divided by 5 is 1, 1 minus x divided by 1 minus x is 1. So then I'm going to caution you to be careful with this negative right here. There's a negative right here. So when you combine it, you are going to say 1 minus 1, which is 0. But you're also going to get x minus negative x. And that's not 0. Because minus negative makes it a positive. It's actually x plus x, which is 2x. So now we have 2x on the top, and on the bottom we still have the 1 minus x. Greater than or equal to 0. So then how do we find critical numbers? You find critical numbers in the case of a rational function like this by making the top and the bottom equal 0. So 2x equals 0, so then obviously x equals 0. That's one critical number. And then if you go 1 minus x equals 0, then x equals 1 is a critical number. So we have two critical numbers. Yes, yes? So again, in the case of a rational function, you have critical numbers from the top and from the bottom, both. So then when I make my number line, I always start with negative infinity and go to my smallest number, which is
0.
Then I go from 0 to the next number, which is, the next one is 0, 1.
1.
It's just 1, not
Yeah,
0,
right
1.
now.
So we have that, right? Then you have 2x, 1 minus x, and both. Yeah? So here we're going to pick negative 1, 0.5, and 2. So 2 times negative 1 is negative. 0.5 times 2 is 1, it's positive, right? And 2 times 2, that's positive. What's 1 minus negative 1? Be careful.
Positive 2.
It's actually positive, right? So that's going to be positive. And what's 1 minus 0.5?
Positive.
What's 1 minus 2?
Negative.
Okay? So then again, with division, it's the same thing as multiplication. 2 negatives make a positive, right? So negative and positive is going to be negative, positive, negative. For our final answer, we're looking at this.
It's a cubic.
So we want to know when it's going to be greater than 0, so we want just this. So it's going to be 0 to 1. And then be very careful, okay? Because we cannot allow division by 0. So even though it says equal to, if we allow x to be 1, then we're going to have 1 minus 1, which is division by 0. We cannot allow x to be 1. So for the 1, even though it says equal to, we have to make it a parenthesis because we can't allow division by 0. Now, on the 0 side, it doesn't matter. The 0 can be on top. It doesn't matter. Right? The 0 is from the top. So that doesn't matter. So that one you can set a bracket on. But remember to be careful with those division by zeros. They will catch you every single time. Alrighty? So that would be our final answer. And now we're going to say bye-bye to Leah.
Goodbye,
Bye, Leah.
Leah.
Bye,
Shall I
Leah.
de-record? Press the unrecord. Shall I hit the
Yes,
record
push the
button?
record button.
Goodbye, Leah. I hope that you're having a wonderful day.
Just even